Hello and welcome back to Series and Sequences. First, I want to thank all the nice people that support this channel by liking and subscribing. In today's part 2, I'd like to start looking at arithmetic sequences. Now, we have established in the introduction last video that a sequence is just an ordered set of numbers that have a certain pattern. Now, what if this pattern were a constant? It could be a constant increase or decrease. More specifically, this pattern is represented by a linear relationship. This special type of sequence with a linear relationship pattern is called arithmetic sequences. So, as an example, we have, let's say, 2, 4, 6, 8, 10, 12, and so on. This would be an arithmetic sequence because there is a constant growth by 2 in order to get the next term. Another example could be 16, 12, 8, 4, 0, -4, -8, and so on. This is also an arithmetic sequence because there is a constant decrease by 4. So if we were to go into a more general sense, the first term, as established before, is denoted by u with an index 1, so just u1. Then, in order to get the next term, which is u2, you need to add or subtract this constant pattern. That is called the common difference, and denoted with a lowercase d. So that means, in order to get u2, you can add the common difference to u1. So first term u1, second term u2 equals to u1 plus 1 difference. To keep it going, u3, the third term, can be written as u2 plus a difference. However, there is another way that you can write this with u1. You can write this as u1 plus 1 difference and plus another difference. So technically, it's just u1 plus 2 differences. And we can keep this going. u4 is equal to u1 plus 3 of these differences. But I think you have already noticed the pattern. In order to find the nth term un, we always need to add u1 with n minus 1 of those differences. So u1 plus n minus 1 times the common difference. Thus here, we have arrived at the general formula for the general term of an arithmetic sequence. So let's take a look at some examples. Let's say an arithmetic sequence has the fourth term u4 given by 18 and a common difference given by -5. So that means we have a decreasing arithmetic sequence. And we need to find u1, the first term, and the formula for the general term. So let's first apply the formula in order to find u1. Here we can set un as u4. So u4 technically is equal to u1 plus 3 differences. This comes from the general formula 4 minus 1 differences, which is the same as 3 differences. Please note in the formula, the index n has the same value as the n on the other side of the equation. And now all I have to do is plug in the numbers I already know. Because u4 is 18, u1 is unknown, and the common difference is -5. If I were to simplify this, I get 18 equals to u1 minus 15. So that means u1 is going to be equal to 18 plus 15, which is just 33. And then I need to find the general formula for the general term un. So un is equal to u1 plus n minus 1 times difference. Now I can plug in the numbers I know. un is equal to u1, which we calculated 33, plus n minus 1 times the common difference, which is negative 5. And then what I can do is open the parentheses here. And finally, we get that un is equal to 38 minus 5n. So here we have successfully found the first term and the general term. So now let's take a look at another more complicated example. Let's say an arithmetic sequence has the second term 20 and the seventh term 55, and we need to find u1 and difference. So now there are two ways that we can solve this. We can write u2 and u7 as expressions of u1 and common difference. This would look like the following. u2 equals to u1 plus 1 difference, and u7 is equal to u1 plus 6 differences. And then instead of u2 and u7, all I can do is plug in the values that were given to me. So here I have a system of equations which we can solve. If I subtract the upper equation from the lower, what I get is negative 35 is equal to negative 5d. So that means the common difference is equal to 7. Now, if the common difference is equal to 7, that means we can easily find u1 since u2 has already been given. u1 is simply equal to u2 subtracted by that common difference. So in our case, it's equal to 20 minus 7, which is equal to 13. Another way that we could solve this is by using u2 and u7 directly. Here, please notice that u2 plus 5 of those differences is technically equal to u7. This simply means between the second and the seventh term, there are 5 differences in between. And then all I can do is plug in the numbers that are already provided for us. So 20 plus 5 differences equals to 55, and 5d is equal to 35, yielding us an answer with a common difference of 7, which is the same as with the method before. And then you can find that u1 is equal to 13 in the same fashion. So either of these methods is valid, both work perfectly, and it's just a personal preference. For me, the second method is always better. So this is enough for today. In the next video, I will show you what happens when we try to add all of the terms in a finite arithmetic sequence. So I really hope to see you there, and have a nice day. Bye.